Hello students, here I am with a new topic, that is inclusion exclusion principle. So inclusion exclusion principle or principle of inclusion exclusion. So first of all you have to learn the theorem. Based on that we are going to do two problems. So this topic is also based on the K2 syllabus 2019 scheme also. So here let us consider two finite sets A and B. If you consider like this two sets A and B, so we can say that this part is, in this part this is A, this is B part, but A union B means the shaded region, and this is the shaded region of A intersection B. So here in this the statement is number of elements in A union B. So this is A intersection B. So number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B, or otherwise mod A union B equal to mod A plus mod B minus mod A intersection B. So based on this we are going to do the statement. We have to do a problem, and if suppose there are three sets A, B and C. So if we consider three sets like this A, B and C, so this part is the shaded region. This is the shaded region of A intersection B. This is the shaded part of B intersection C, and this is A intersection B intersection C. This middle part is A intersection B intersection C. So now if it is given there, the number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus number of elements in A intersection B intersection C, or otherwise you can write this as mod A union B union C equal to modulus of A plus modulus of B plus modulus of C minus mod A intersection B minus mod B intersection C minus mod C intersection A plus modulus of A intersection B intersection C. So this is the concept given here for three sets. If it is for three sets you have to use this statement, and if it is for two sets we can use this statement. So now I shall move on to the problem. So the question is, out of 200 students, this is the first question. So out of 200 students, 50 of them take the mathematics, 140 of them take the course English, and 24 of them 140 of them take the course economics, and 24 of them take both the courses. So here both the courses have been scheduled the examination for the following day. Only those students who are not taken any of these courses are able to go to see the movie. How many students will be able to go to see the movie? So here so we have to do this problem, and here it is given that n total number of students let us consider to be 200. So how will you consider? So first of all the students, let A be the set of all students, A be the set of all students who take mathematics, and B be the set of students. So let us take A takes the subjects mathematics, and B denotes the set of students which takes economics. So here n of A, so n of A union B, n of A, n of B, n of A intersection B, and what is the total number of students? So here total number of students is given as 200. So let us take here total number of students is equal to 200. Let us take to be n equal to 200. So now let us take the students which takes the A denotes the set taking mathematics. So therefore n of A equal to, let us take to be 50, and B denotes the set that is given here. What is given here? So 140 of them take, 50 of them take the course mathematics. N of A is 50, N of B is 140. 140 of them take the course economics. So this denotes mathematics and this denotes economics. So, and also one more condition is given here. 24 of them take both the courses, that means n of A intersection B. By the principle, two sets are given here, so we can apply the principle of inclusion and exclusion. N of A union B equal to n of A plus n of B minus n of A intersection B, that is equal to 50 plus 140 minus 24 equal to 166. But what is the question given here? What is asked here? N of A union B. A union B, number of elements in either A or B. So here n of A union B, that means totally 166 students cannot go to see the movie. As they have to give the examination of mathematics or economics. So either mathematics they have to leave, or they have to give the examination of economics. So the number of students who can go to see the movie, how much students went to or able to go to see the movie, we have to say that. So total number of students, so therefore the total number of students is equal to 200. Therefore those who went for this movie, those who are able to go to the movie, is total number of students is equal to n and minus 166, that is equal to 34 students they can go to see the movie. So total number of students is 34, they can go to see the movie. So first of all, this is a very simple problem. Here it is given here, in out of 200 students, n is given here. Sometimes n will not be given here, but so in this case n is given here. So n of A union B equal to n of A plus n of B minus n of A intersection B. You can apply in this formula and you can find out the answer. Now, next one is counting the number of elements of intersection in a class of students. In a class of students ongoing a computer course, the following were observed. So out of a total of 50 students, 30 knows Pascal, 18 knows Fortran, 26 knows COBOL, and 9 knows both Pascal and Fortran, 16 knows Pascal and COBOL, 8 knows Fortran and COBOL. So 47 know at least one of these three languages. So the question is, determine how many students know none of these languages. Second part, how many students know all the three languages. So first of all, let me take to be three subjects. So here it is given here, let us take to be A, B and C. What is A? What is B? So we can take it as A as 30 students who know Pascal, and let us take B as 18 students who know Fortran, and 8 students as not 8 students, it is given here 9 students know both Pascal and Fortran, 16 knows Pascal and COBOL. So we have to take first, let us take this to be, so this is A, this subject is B, and COBOL let us take it as C. So n of A, number of elements in A is equal to 30, number of elements in B equal to 18, number of elements in C equal to 26. Now A and B are Pascal and Fortran. So therefore A intersection B, this is A and B. So it is A intersection B is 9, and A intersection C, Pascal and COBOL. So A intersection C is 16, and Fortran and COBOL, B intersection C is equal to 8. So 47 knows, 47 know at least one of these three languages, it is given here. So how can we take it as? First of all, Let us see. We know that 47 students know at least one of these three languages in the class of 50. So total number of students is equal to 50. So that which is asked in the question. The question is how many students know none of these languages. So 47 knows at least one of these languages means total number of students is 50. Therefore, what is the condition here? It is easy, no more calculations are needed. The number of students who do not know any of these three languages. So the number of students who do not the number of students who do not know any of these three languages is equal to total is 50 minus 47 equal to 3. Now 47 knows at least any one of these three languages. That means 47 students knows A or B or C. That means number of elements A union B union C is equal to 47. So now the next is we shall take it as the three cases A, B and C means we can apply the inclusion exclusion principle, that is n of A union B union C equal to n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. Now we shall substitute all the values of n of A, n of B, n of A union B, all these values in this equation. So n of A union B is 47 equal to n of A is 30 plus 26 plus 18 minus n of A intersection B intersection C. For A intersection B is 9, n of this is 9, n of A intersection C is 16 and n of B intersection C is 8 plus n of A intersection B intersection C. So that we do not know, and simplifying this, n of A intersection B intersection C is equal to 6. Hence there are 6 students in the class who know all the three languages. Now we shall move on to the next question. In a discrete mathematics class, every student is a major in computer science or mathematics or both. The number of students having computer science as a major, possibly along with the mathematics, is 25. The number of students having mathematics as a major, possibly along with the computer science, is 13. And the number of students majoring in both the computer science and mathematics is 8. How many students are in the class? So first let us take how will you take the cases, set of students majoring in computer science, set of students majoring in mathematics. So here let A denotes the set of students majoring in computer science and B denotes the set of students in the class majoring in mathematics. That means modulus of A or number of elements in A is equal to 25. Here also it is given that number of elements in B is 30. So let us take it as give B n of B or modulus of B equal to 13. Therefore A intersection B is set of students in the class majoring mathematics and computer science, and here denotes the symbol intersection. So therefore mod A intersection B is equal to 8, or you can write number of elements of A intersection B is equal to 8. Now we have to find out mod A union B. By using the principle of inclusion exclusion, we know the formula right here, mod A union B equal to mod A plus mod B minus mod A intersection B, that is equal to 30. Therefore there are 30 students in the class, which is therefore they are either they are majoring computer science or they are majoring mathematics. Now next one, how many positive integers are not exceeding 1000 or divisible by 7 or 11? How many positive integers not exceeding 1000 or divisible by 7 or 11? A is the set of positive integers not, let us take first the set of all positive integers not exceeding 1000 that are divisible by 7. So here it is given 1000 is divisible. How many positive integers not exceeding 1000 are divisible by 7? So not exceeding 1000 are divisible by 7 either or by 11. So here the question is not like the previous cases. So previous problem, it is not like that. It is not clearly given here the details. So here in such situation, let us take first the set of positive integers divisible by 7 to be A, and the set of all positive integers not exceeding 1000 that are divisible by 11 to be B. Now A intersection B equal to the set of all integers not exceeding 1000 that are divisible. A intersection B, A is not exceeding divisible by 7, B is not exceeding divisible by 11. So therefore the set of integers not exceeding 1000 that are divisible by both 7 and 11. Now here one thing is in this such type of problems you can apply the float operator. So the float operator is the greatest integer which is less than the given value. So sorry, the greatest integer which is less than the nearest value which is less than the nearest integer which is less than the given value. So therefore we use the floor operator here. Modulus of A, what is modulus of A? So is it possible to find out the 1000 possible integers which are not exceeding 1000 or divisible by 7? It is not manually possible to calculate the value as manually. So such situations we apply the floor calculation. So number of elements in A is equal to floor of 1000 divided by 7. Here we use the floor operator. So now here 1000 divided by 7 equal to 142.5, the nearest value which is less than this value. So therefore the nearest integer which is less than this value is equal to 142. Now 1000 divided by 11, floor value is equal to 9, floor of 19.9 equal to 90. Now the next one is mod A intersection B equal to 1000 divided by 7 into 11, that is equal to the floor of 12.98, that is equal to 12. So therefore by using the principle of inclusion and exclusion, mod number of elements in A and B equal to number of elements in A plus number of elements in B minus number of elements in A intersection B, that is 142 plus 90 minus 12 which is equal to 220. Therefore there are 220 positive integers not exceeding 1000 that are divisible by either 7 or 11. So this is the case in this question. I think it is very easy to use the floor operator because we are not able to find out the value which are positive integers which are not exceeding by 7 or 11. It is the manual calculation is very tough. Such situations we can apply the floor calculations, but in pigeonhole principle we use the seal operator. Remember that in pigeonhole we use seal operator, but in principle of inclusion and exclusion we apply the floor operator. Now the next question. Suppose that there are 1807 freshmen at your school. Out of this 453 are taking a course in computer science and 567 are taking a course in mathematics and 299 are taking a course in both computer science and mathematics. How many are not taking a course either in computer science or mathematics? So let's take first of all totally the total value is given as 1807. Let n equal to 1807. Let us denote A to be the set of all freshmen taking the course in computer science. B denotes the set of all freshmen taking the course in mathematics. That means number of elements in A is equal to 453. Number of elements in B equal to 567. And number of elements in A intersection B is 299. By the principle of inclusion exclusion, you can write the formula mod A union B equal to modulus of A plus mod B plus minus mod A intersection B, that is equal to 721. So therefore the total number of freshmen is equal to 1807. Therefore the question asked is, what is asked here, how many are not taking a course either in computer science or in mathematics. That means the total number of freshmen is 1807 minus 1807 minus the number of persons who are taking either any one of the subjects. The number of freshmen taking either any that is either computer science or mathematics. So that is equal to 1807 minus 721 equal to 1086 persons are not able to take. That means they are not able to take the course either in computer science or mathematics. Now next question, a total of 1232 students have taken a course in Spanish, 879 have taken a course in French. So yes, here let us take how much a total of students. This is Spanish. Let us take Spanish is as 1232, and those who are taking French 879, and the 114 have taken a course in Russian. R is 114. So 103 have taken the course in Spanish and French, and 23 have taken a course in Spanish and Russian. 14 have taken the course in French and Russian. So like this you can write this. Now if 2092 students have taken at least one of Spanish or Spanish, French and Russian, at least one of these, how many students have taken the course in all the three subjects? That means it is given here at least one of Spanish, French and Russian is given here. That means they have taken either Spanish or French or Russian. So it is given here that number of elements in S union F union Spanish or French or Russian is equal to 2092. It is given here, but it is asked to find out the how many number of students have taken a course in all the three subjects. That means you have to find out the number of elements in S intersection F intersection R. You have to calculate. So therefore let us take S denotes Spanish, F denotes French, R denotes Russian. Therefore number of elements in S is 1232, French is 879 and Russian is 114. Therefore number of elements in S intersection Spanish and French is 103, Spanish and Russian is 23, French and Russian is 14. Either Spanish or French or Russian is 2092. By using the principle of inclusion and exclusion, we know the formula. Write the formula first, then you have to substitute all the values. So therefore you have to find out mod of S intersection F intersection R, that is equal to, totally on calculating you will get 7. Therefore there are 7 students who have taken the course in Spanish and French and Russian. That's all. Now at last the case. So if there is 3 cases also, 2 cases, 2 sets means we have written the formula, based on that we have done the problem. If there are 3 cases, based on that 3 sets means based on that we have done the problems. Now comes the generalization. Generalization of the principle is, if suppose there are A1, A2 etc. AN, there are finite sets, therefore modulus of A1 union A2 union etc. mod AN equal to summation I varies from 1 to n of AI. First we have to write number of elements in A plus number of elements in B plus number of elements in C. So that is given as summation I varies from 1 to n, the modulus of AI minus summation of AI intersection. Next, considering 2 elements. So two elements means ai intersection aj. So summation of 1 less than or equal to I less than j less than or equal to n. Now at last we will be considering second term. Next അതായത് simple. First term is positive, second term is negative, next term will be positive. At last term we will be considering like this: summation of I less than or equal to j less than or equal to k less than or j less than k less than or equal to n, that is modulus of ai intersection aj intersection ak, etc. The last term minus 1 raised to n minus 1 a1 intersection modulus of a1 intersection a2 intersection etc intersection an. You learn this generalization also. Okay, thank you.